Now that we have a finer grain analysis of the main non-volitional and volitional neural circuits underlying human thought and planning, we are in a position to ask how these neural circuits interact. The authors of this review article suggest that there are three main modes of human thought: one that they regard as spontaneous or relatively unconstrained, another that they regard as constrained by non-volitional factors, and the third which they regard as constrained by volitional or deliberately set top-down constraints. This latter type would include the neural circuitry that underlies free will, which would itself include the dorsal attentional network, the frontal-parietal control network, and the cingulo-opercular control network. Let's first look at how they characterize the relationship of these main networks in the case of spontaneous thought. In this category, they would put dreaming, daydreaming, and the brainstorming stage of creative ideation. The arrows indicate likely paths of causation, and the thick arrows indicate the dominant source of causation. In the case of spontaneous forms of thinking, they would argue that memories and associations coming out of the hippocampal formation, as well as the spatial processing circuitry of the medial temporal lobe, tend to drive cognition. There is relatively little in the way of top-down constraints imposed from the frontal executive areas, though there may be some in the case of creative problem solving. Or rather, in the case of creative problem solving, there would be an alternation between spontaneous thinking and idea generation in light of certain specs or criteria that need to be met, followed by the invoking of a top-down editor realized in the volitional frontoparietal control network that sifts through the possibilities generated in the first stage, keeping only the good ideas and throwing away the not-so-good ones before beginning the brainstorming phase again, and so on until an adequate solution is reached. Next, let's look at how they characterize thought processing in the case where there's non-volitionally constrained thinking. As you can see, in this case, the dominant outputs driving thought processing come from forms of bottom-up salience that specify what should be processed with highest priority. In the case of the ventral attentional network, bottom-up salience specifies what should be attended to next. If this happens to be something moving suddenly in the outside world, we can talk of exogenous attentional capture. This is why we find blinking or moving advertisements on the internet so distracting. We can't help but have our attention grabbed by such changes in luminance, and advertisers know this, and that's why they do it. On the other hand, there are many other sources of salience that are not subject to volitional control. Another might be the outputs of the amygdala, specifying things that are potentially dangerous or threatening. Not surprisingly, an overly active or underinhibited amygdala may be related to anxiety disorders such as post-traumatic stress disorder or PTSD, and certain forms of OCD, which result in incessant thoughts that are not subject to volitional top-down regulation. Another form of such bottom-up salience might be the social error signal associated with feelings of shame and guilt that can happen in the case of an overly active Area 25 or subgenual cingulate cortex, as we discussed earlier in the case of depression. In this case, people tend to again and again return to the same thoughts involving self-loathing or social slights and errors that lead depressed people to suffer so much emotionally. All of these various forms of bottom-up salience constrain processing in a way that is very difficult to volitionally control. Finally, let's look at how they characterize thought processing in the case where there is top-down or volitionally constrained thinking. Here, the frontoparietal control network drives brain activity in the other neural circuits to meet the conditions demanded by that network. It operates cooperatively with the cingulo-opercular circuitry that keeps us on task. And it harnesses the dorsal attentional network so that we can fulfill our highest level cognitive goals in an optimized sequence when attending to the outside world. Moreover, it harnesses the internal simulation circuitry of the default network when we deliberate in our imaginations. Central to top-down control is likely to be Area 10, or rostrolateral prefrontal cortex. This area is perhaps the highest in the pecking order of executive planning circuitry. People who have lesions in this area might have trouble forming appropriate high-level plans and sequences of actions. For example, think about how complex it is to make a cake. There are probably dozens, if not hundreds, of small steps that all have to be executed in the right way and in the right order, or else you won't end up with a good cake, even if you have all the perfect ingredients for a cake. Instead, you might end up with mush. Timing and sequencing matter. Certainly, what sets volitional processing apart from non-volitional processing is the specification of top-down constraints or criteria that then influence bottom-up processing in such a way that just those constraints or criteria are met. But it would be wrong to think that executive control areas, such as Area 10 or the DLPFC, are alone adequate for volition. In addition to having a high-level plan, you need to have ways of executing the plan. That is, you have to come up with more concrete plans than, I'm going to learn Swahili. You need more immediate plans that will get you to order a book about how to learn Swahili. And of course, you also need a motoric system that is capable of carrying plans out using your body in the world. Earlier in the course, I gave the metaphor of a car. In order to drive, you need a driver or executive with a plan about where to go next and where to go long term. This would include areas such as Area 10 and the dorsolateral prefrontal cortex. But you also need gas, or you won't be going anywhere no matter how good your plans might be. This is analogous to the anterior cingulate circuitry that keeps us on task and may be associated with both error detection so that we can get back on task, and the subjectively experienced feeling of drive or willpower. If this circuitry is knocked out, people can get what's called akinetic mutism, where they appear to lose all drive. Typically, they just lie there catatonically. It's not that they become unconscious, rather, it's that they don't see the point of striving to do anything. Having the ACC in place gives one the willpower to see plans through. In the next sections on willpower, we'll learn more precisely how this works in terms of cognitive control of the peripheral nervous system. But having anterior cingulate circuitry in place without an ability to plan, coming from rostrolateral and dorsolateral prefrontal areas, might be a bit like having a full tank of gas without having a destination in mind to drive towards. And of course, you also need to have a steering wheel that connects to wheels that can turn, which is analogous to having a motor system that allows you to carry out your intentions. So, free will or volition is not a single thing. In fact, volition is not a thing at all. It's a series of correctly sequenced, interacting processes or operations, just as driving is not a thing, but a cascade of processes that have to be carried out in the right order.